Hey guys, Keith here. Um, I wanted to make a video to bring you up to date with the features that have been added to xLights from versions 2018.1 through to 2018.6. Because I've left it 6 releases, there's a whole stack of stuff here, so I'm going to split it as I have done in the past by a video on xSchedule and then a video on xLights. This one will be the xSchedule video. It's going to be a little bit shorter. There's not as many enhancements, although there's some things that are quite involved that I'll go into. So let's start with back in 2018.1. These are basically in chronological order, so it'll jump around a little bit. And I know not many people will watch it, but hey, what the hell, at least it'll record somewhere what's going on, and if someone ever gets around to updating the manual, they'll have something to base it on. So let's start with the first one, which is xSchedule output process, which can scale pixels from 3 to 4 channels per pixels. This has been introduced because there are some people out there that have RGBW pixels or even WRGB pixels. And obviously xLights does not support them natively. We do have an RGBW type, but it's really for a dumb prop, which is RGBW, rather than, every pixel has 4 channels. xLights natively, of course, just works with the 3 channels. And when we do RGBW, we turn the RGB channels off if the 3 channels are all the same value, and instead we turn on the white channel. And it's very hard for us to introduce RGBW natively into xLights. It gets really messy and difficult to do because everything is just so fundamentally based on the concept of RGB. But one of the things that I could do in the scheduler is if you had, let's say you had 100 pixels, which were RGBW, which is going to take 400 channels. But if you were to define a model in xLights, which instead was 300 channels, and then set it up in your controller as 400 channels. And so what you would do is you would sequence the first 300 channels and then leave 100 channels black or blank, not use them, not assign them to any model. What I can do in the scheduler when I'm playing things is I can take those first 3 channels and I can stretch them out to use the 4th channel. And then I can take channels 4 through 6 and I can stretch them out and place them in the positions 5 through whatever. You get what I mean. So basically what I do is I spread everything out so that it uses 4 channels instead of 3 channels, and where the RGB are the same value, I actually zero them out, and instead I set the 4th channel, which is the white channel, to a particular value. And that, in that way I can take just raw RGB data and allow you to exploit some of the capabilities of your RGB pixels. Now, of course, it's not perfect. One of the reasons you might have RGBW is obviously to exploit the fact that you want to mix the white together with the RGB, and that's not possible at the moment. So how do you do that? It's one of these output processes. Output processes are a list of things that gets applied to the schedule data just before it gets written out. And so you have this now, this add 3 to 4 channel map. You choose a start channel. You can actually here, you can actually say, actually universe 31 start channel 1, and so it works out what that actually is. You can specify the number of nodes. So in our 100 pixel string, this would be 100. You can specify whether it's WRGB or RGBW, and of course you can explain what you were doing or why you added this in. And that will now stretch out for 300 channels starting at universe 31 channel 1, and it will stretch those 300 channels out to actually occupy 400 channels, which of course your controller can then send out to your particular prop. So hopefully that's clear. These sorts of things, unfortunately, scheduling gets a little bit difficult at times to explain. Controller status to the xSchedule UI. So this is something that Billy introduced just before the end of 2017. I added this this section down here, which actually pings the controllers once a minute and shows you the status. Everything here is offline. My controllers are packed away. But if you go to the web interface, and hopefully this is going to work, which it is, Billy has replicated that controller status onto your web UI. So when you're looking at it on your phone or on your tablet, you can see the status of all of the controllers in your show, as well as all of your show as well. So a great way to monitor the health of everything. Add a reset all schedules function to xSchedule. This is kind of important. So if I take, I don't know, let's take this test sequence here, and I was to schedule it to be on basically now, I think that would, yep, there it goes, it starts. And if I was to stop it at this point, it goes into this stop state, and there's no way to get it out of this stop state easily other than shutting the scheduler down and restarting it all. And so I added to these buttons an item here. Let's call it reset, and I just have to find it. There's a reset all schedules in here somewhere. Yell when you see it. Restart all schedules. There you go. And what that will do when you come out here and you click it is it will reset this schedule. So the schedule that's currently stopped will go back into a state where it hasn't been anything. And of course, because it's still ready to be played, it will immediately start to play again. So basically clears it and allows it to play again. So if you stop your schedule and then you say, well, actually it should still be running and now I want to let it run again, you can click on a reset button like that and it will release the schedule again and it will play as if it was scheduled, which means it will stop at the scheduled time. Whereas if you instead had said, oh, actually, now I want to restart that thing and come down and click play scheduled, selected, you're playing it immediately. So it won't stop. It will just keep playing. And so you'd have to manually stop it. By having the reset button, you basically just re-enable the schedule, although, of course, it will pick it up from the beginning of the schedule. So that's what that one's about. This one here, I'm actually showing this one on both the xSchedule video and the xLights video because Dan has upgraded the minimum standard. So OS X now needs to be at least version 10.10, and that applies both to xSchedule and to xLights going forward. Okay, so in 2018.4 is when I have introduced all of the event triggering. So let me show you that. I'm not going to actually demo it live because it's a little bit involved, but event scheduling is accessed here on the events menu. And here you get to define a bunch of events that you want the scheduler to listen for. And what it's going to do is it's going to spawn a thread for every single event, and it's going to sit there either listening to the network card for a particular type of network packet, or it will open up a connection to a serial port and it will listen to a serial port. And basically it will wait for something to happen. And when something happens, you get to choose what xSchedule does. So if you click on add here, it comes up and you get to choose what sort of thing you want to listen for. So if it's E131, that means that if you had something else on your network that was sending out E131 data, like, I don't know, an FPP or maybe some commercial device that's sending out E131 data, you could choose to listen for a particular universe and a particular channel. I believe these have to be unicast, although I wouldn't swear to it. Maybe it will listen to multicast as well. And then you get to choose that channel, and you can choose one of these types of conditions, like you can be continuous and say, I'm going to listen for continuous change on that channel, or just when it changes, and the value. And then based on that, you can then cause it over here to do something. So you can name it. And then all of those commands that you saw me setting up the keyboards for, all of these commands are available. And of course, some of those things require parameters. So for instance, if I wanted to control the volume that's being played out of this scheduler based on a packet that's coming from another player, I could get in here and I would have to set a value now, because the volume is set between 0 and 100. If it was just coming in as a value between 0 and 100, then I'd use the percent channel value. But if it was coming in as a 255 and I needed to scale it down, I'd type in percent channel value 100. And what that will do is it will take the value that comes in on channel 1 in universe 1. We'll set it to be on change. So every time it changes, we're going to fire this event, and it's going to set the volume to be a value between 0 and 100. Now, of course, the value actually comes in between 0 and 255. So what it will actually do is it will scale it so that when it's 0, it comes through as 0, but when it comes through as 255, it will scale it to 100, and when it's 127, it'll scale it to be 50. So that sort of proportional scaling. And so now this is reacting to that E131 data. You can also do it from data itself. So what this is going to look at is it's going to look at channel 1 in this case, although you can of course set this to be, universe 31 start channel 1. In the currently playing sequence. So this is actually going to look inside the sequences that xSchedule is actually playing. And so you can actually create a channel inside your sequence and say that that particular channel is going to be my volume. And you can then vary the volume of your song as played back by xSchedule using a channel inside your sequence file. And you can use ramps to ramp it up and put an on effect when you want it on at full volume, etc. So in theory, you can basically control the scheduler from within the sequence itself, and it has all the same sort of continuous or on change, or when it hits a particular threshold, etc., etc. All of that stuff's there. The serial one, okay, so this is basically, it supports DMX and OpenDMX. I'm a little suspicious about OpenDMX. I would stick with DMX if you can. And so basically what it would do is it would let you connect to a serial port to a DMX device and have that DMX data coming into the computer, and it would do exactly the same sort of reaction. OSC is a little different. OSC is the open sound control protocol. This is a protocol which is supported by, I've got a couple of iPhone apps that will send this out. A certain amount of professional equipment uses open sound control as well as a way to control multiple devices within a show. And here you get to say, you get to give an arbitrary path that you want it to respond to. So you might say xLights/volume. You set up first parameter, you might say, well, that's going to be a floating point number, which would be a number then between 0 and 1. And then you would come over here and you have to decrypt my very complicated text here. But basically what you would be doing is you would be taking a parameter. So it would be, percent P, because it's a parameter, it's a floating point number. Sorry. Sorry, I have to say which parameter. So it's going to be parameter 1 of type floating scaled to a value of 100. And so it will take that value between 0 and 1 and scale it up to a value between 0 and 100. And it knows that because it says it's a floating point number. And parameter 1. If you want to use parameter 2, you would obviously define it there and use it appropriately. So that's OSC. FPP exploits the FPP eventing. So FPP has the ability to both listen to and emit events. And this will listen for FPP events, and it's got a major and a minor ID. You can set which one it is. This one's a little bit more complex. You obviously don't really have any parameter here other than the actual ID numbers themselves. So you're probably not going to do a set volume to, but you might use it to, I don't know, trigger playing a video or something. Might be an idea. ArtNet is just like E131, except obviously it's the ArtNet protocol, so it's listening for that. And law, this is the stuff that Gil introduced, where you get to choose a unit number, a port, etc., and you can hang something like an input pup or something onto your law network. Now, it has to be a separate network from any law network that you're sending data out to. So once you choose to listen, you can connect multiple pups onto that network, but you can only listen. You can't write any data out via that network. So you'd have to put another law dongle if you wanted a network that you were writing out to. But this allows you to do that. So now you can cause events to fire inside the scheduler using this particular thing. Now you can have as many of these events as you like. You can just keep on adding them, and they will all run in parallel behind the scenes. It's your problem if they all issue events and the scheduler starts going nuts because you've created so many of them, etc. That's a little bit on you. Now, there is a feature coming up in version 7, which I won't cover in any detail here, but one of the things, once you've got all of these events, it's all well and good to have events which allow you to stop and start sequences and the like. But one of the other things you'd like to do, particularly in things like, a Halloween show, or, one of the things I'm contemplating is having a button out where all my guests are, where they can come up and push and call Santa, and I will cause it to play my virtual Santa. Now, I want to make it work such that if they press the button, virtual Santa's already there. Obviously, I don't want to stop him and restart him. That would look a little bit weird. But if he's turned off or the video's just ended, they could press the button, he would come back again and he'd do his thing. And I kind of think that would be kind of cool. Now, I don't want it to interrupt my show. I still want my show to go on as normal. And that's not available in .6. But come .7, you can actually have these disconnected things going on, including playing, a limited set of lights. So in a Halloween thing situation, you might have I don't know, you might have, a Halloween tunnel where, as people walk into it, it flickers or something. And so you want xSchedule to flicker the lights, but only when it gets triggered, and you don't want it to get into the way of the rest of your show that's going on, which is playing a song and all your lights are dancing. And so this eventing and the ability to play multiple concurrent things going on at once is where xSchedule is going come .7. So hopefully that makes some sense and I haven't lost you all. On the output side of this, so one of the things that you get to once you realize that, hey, that's kind of cool, if we go into advanced, there are actually some additional output items here as well. So being able to listen for FPP events is great, but what happens if you actually want to send out an FPP event? So again, you get to give it a name, you get to choose one of those event IDs and decide that it's going to be sent out. And that will obviously broadcast that out on your network, and any of your FPPs will be able to listen to. So you could once again set up an FPP to play a video when it receives the event and do that sort of thing. So that's possible. The other thing I added was a generic serial. So what this lets you do is this lets you give it a name, pick a port, pick a configuration. So this is basically the number of stop bits. And then you can come down here and you can basically send arbitrary data out to a serial port. So if you've got a serial port controlled projector that needs a specific set of codes, then you can send that code to the projector and you might turn it on or whatever it happens to be. Now, you can type in text obviously here, but in many cases you actually need to send binary data, and to do that you would do that using hexadecimal data. So if you needed to send a hexadecimal 16, you would hexadecimal 10, which happens to be 16 in decimal. That's how you would send the 16 code. And then if you had to zero terminate it, you would type a /x00 and so forth. And you can build these strings out as you need to send to your projector or to any other serial controlled device that you want to control. Using things like the delay down here, you can also say, oh, let's start that 2 minutes into this current step. So you might play your song and you want to turn the projector off 5 seconds towards the end, and so you could control it that way. So hopefully that makes sense. I think that will close a gap with controlling serial devices and save me having to write a whole bunch of very specific stuff. Reworking remote. So you would all know that we have all of these remote modes, FPP, which obviously syncs with your FPP, both as master and remote. I also introduced an OSC form of this, which in theory would let you potentially sync with other things. I've now added in ArtNet. So if you are using an ArtNet timecode, which some commercial setups might use, you can now make FPP an ArtNet slave or an ArtNet master and issue the timecode. Now, because the ArtNet timecode is basically zero-based, it doesn't have the concept of, you know, which song's playing and that sort of stuff. It will always start with the very first playlist here. And so if it receives a timecode of 0, it will start at the very beginning of the first song within that playlist. Now that playlist happens to be 46 seconds long, so when that time code reaches 47, it will start playing the second song and so forth. And so it's basically adds up all of these times to work out whereabouts it should be up to, and that's where it jumps to and plays. So you can sync things up. So that's that one. Screenmapper. Okay, so Screenmapper it's an interesting concept. So we've had the ability to do things like write text onto a matrix. There's even a hidden API that lets you have an arbitrary program write any data onto pixels. But one of the things that is really cool that you can use with some software products is the ability to actually take a section of the screen and write it out. And I think, yeah, this is the one where I've actually set it up. So if I play this, you'll see that what I've done is I've actually mapped the top left-hand corner of my screen onto this virtual matrix over here. And when I move my mouse over things on the menu, you can see how over on the right-hand side there that the menu lit up. All right. So this is actually a live representation of this upper left-hand corner of my screen on a virtual matrix. Now, of course, you don't have to output it to a virtual matrix. You can output this onto anything, your Megatree or so forth, or your P10 panel or your P5 panel or whatever it might be. Now, if you were to then in that part of the screen put a live camera feed from your webcam, you could effectively webcam directly live onto your P10 panel via that screen mapping mechanism. The way you do it is if we go in here, basically there is a new output type that you can add, which is called a screen map. The screen map, you have to choose the matrix that you're going to write out onto. In this case, I've chosen my virtual matrix. You can choose how it writes out. So in this case, I'm just overwriting all the data there, but you could do all the usual masking and blending and averaging and all of that sort of stuff. You get to choose how it gets scaled because you may be scaling the image. It may not be exact. You also get to choose the position. So if you look very carefully up here, you can see that there's this grayish area with a red border. And as I increase the X position, that box moves over to the right. And as I increase the Y, it moves down the screen. And that's the area that is going to be copied. So now it's over screen and events. You obviously get to define how large it is as well. And the priority is used for ordering things. And so now when I play it, I'm going to see this section of the screen played. Right, so there's the screen and the events. Actually, it seems to be, maybe it's a little bit off. I have to look at that. Anyway, but you get the idea. So a potentially very powerful mechanism for displaying arbitrary data real time, and that can be anything, right? You could take a live feed from anything, from Facebook or whatever else, and put it up onto your show, and it will rescale the images and display it. So that's what that one's all about. The law output to control xLights to control CCR, pixels, and light. Okay, so this is something that Gil added. He actually added it in xLights, but because xLights and xSchedule are obviously intimately related, when he added that new optimized law output, which I'll cover in the other video to some degree, that's automatically now supported in xSchedule. So when you define an advanced law output in xLights and you start to play the sequence on xSchedule, it will take advantage of that same advanced optimized output when it plays out to your lights, and you'll get the same enhanced performance that Gil delivered with those changes. xSchedule will now stop at the end of FSCQ if it's shorter than the audio file. Doesn't happen very often, but some people actually deliberately cut short their sequences. They write their sequence to be shorter than their audio file. Previous to now, if you did that, xSchedule would actually basically play blackness until the song finished, because everything was tied to the length of the audio file. Now what it will do is when it gets to the end of the FSCQ file, if the audio is not finished, it will actually turn the audio off and move on to the next step. The law event stuff. Okay, so this is Gil's enhancements, which I've already been over, which is those law events, which I showed you on the other screen. So, and that's it. That's all the changes to xSchedule since the new year. It's still early days, obviously, but I think there's a bunch of new and interesting functionality that's turning out in the scheduler, and hopefully it's even more powerful for this year. And there's plenty of time left to introduce a whole bunch of new stuff. So thanks, guys. I'll write another. I'll do another video now, which will go over the xLights changes.